Hello, welcome to Ekidel, where we train future civil and structural engineers. My name is Fashe Ochet. Today, we want to quickly highlight what we have to do on this particular, what we have for you today. Today, we want to look at mainly manual calculation of your load, roofing loads. Is that okay? Manual calculations of your roofing load. Looking at this structure is a steel roof, isn't it? It's a steel roof, and you expect us to calculate the load and load it properly, isn't it? So on that note now, I want to say, first of all, carry your biro and also your book, because it's going to be more of manual calculation. And if you come to this place now, definitely I'm going to be explaining some things to us, which we are going to be using our calculator to now begin to calculate, and you need your biro by your side to be writing those values. Is that okay? You need your biros to be writing those values and all the calculation, how you are getting them, so that you now know how to now load this particular roof properly. Is that okay? All right. So, and one thing you should know before I forget, you know that definitely this place there are going to be ceilings. Am I correct? Ceilings around this place. Is that okay? Either POP, that's maybe they want to use POP or PVC or any type of ceiling or gypsum ceiling board. All of that. Is that okay? We are going to go into that, and also the roofing sheet itself. All of them, we are going to be calculating all of that. So, all right, let's now move into the action. I want to say, please like this video, because in the course of this video, I bet you might be carried away and forget to click on like button. So in order not to forget, I want to say at this point, click on like button and also subscribe if this is your first time on this channel. Is that okay? All right, that is fine. Okay, so let's now start. Let me click on this, then right click. I come to what? Edit load. Coming to my edit load now, I'll come to my full uniform area load. I'll click on it, and once I click on it now, coming to this place now, if you look at this place, we have what? Looking at it, we have a dead load. Am I correct? And also live load. We have dead load and live load. So let's start with a live load first. Is that okay? Let's start with our live load first. Looking at our live load according to Eurocode 1, 1991, section 1, subsection 1, it says that the characteristics imposed load, that is our QK, is between 0.5 to 0.6 kilonewton per meter square. You know that when you are using Eurocode, it's this with what? With a meter square. So now, since the Eurocode have already helped us that our characteristics imposed load, which is the QK, is what? Is a between 0.5 to 0.6 kilonewton per meter square. Now, depends on the slope. Now, for non-accessible roof, you know, there are some roofs that are not accessible because once they finish roofing because of the slope, isn't it? So in those cases now, we have what we can reduce the load to what? 0.3, between 0.3 to 0.5. Are we together? So, but the most commonly used design value is what? 0.6 kilonewton per meter square. So in terms of your imposed load, according to Eurocode, if you are using Eurocode, is what? Is at 0.6 kilonewton, which means in this place now, we are going to enter 0.6. Are we together? 0.6 kilonewton per meter square. I'll come here now and highlight it, and let's leave it there and let it come up. Can you see now? So loaded. That's according to Eurocode when it comes to live load. Is that okay? Because this one is for what? For maintenance. Definitely there will be maintenance. Maybe they want to, people will climb the roof and also try to maybe add one or two things in terms of let's say your panel, solar panel or something like that, or any other thing. Is that okay? So this one now takes care of what? Of that load. Are we together now? This particular value now takes care of what? Of that particular load. Now coming to that is that for live load, straightforward. That's that. But where the work now is this what? Our dead load. This is where the work is. Now in this dead load, it's now first of all, what you need to know is that your roofing sheet, your roofing sheet that we are talking about, all this roofing sheet, whatever kind of roofing sheet you are using, they have their thickness. Am I correct? They have their thickness, and if they have their thickness, if we have their thickness. So we are going to work based on the thickness of what, of your roofing sheet. But before then, you should know that the density of steel is what is the density of our steel is what is 78.5 kilonewton per meter cube. That is the density of our steel. Don't forget this, because we are going to make use of them very well. Make use of this value, 78.5 kilonewton per meter square. Now, if we have our density of a sheet of steel to be what, to be 78.5 kilonewton per meter square. Now the question now is the type of roofing sheet we are using. What is the thickness? What is the thickness? So for instance, we are going to start. So for instance, let's say we are having a sheet, our roofing sheet, to be what, 0.5. So 0.5, as I said, is more of manual. We are going to do a lot of manual calculation here, a lot of things. So now what we want to do now is to calculate our roofing sheet dead load first. What we are trying to do now, I repeat, is to calculate our roofing sheet dead load first. Now, based on our thickness of the roofing sheet, we have a 0.5 millimeter, and we want to be what, to be in a meter. So it will now be what, divided by what, 1000, give us what, 0.005 meters. That's what we are having. So we have converted 0.5 millimeter to meter, which gives us what, 0.005 meters. Now, having done this one now like this, the next thing now, based on the thickness of our roofing sheet that we are using, is what, 0.005 meters. So we now multiply it now. What we have now, this equals to this. Sorry, let me take it. 0.0005. Now multiply by the density of our what, of our steel, which is what, 78.5, which is equals to what? Can you see? It's giving us 0.03925. That's kilonewton per meter square. That's what it's giving us. So approximately we are having 0.04 kilonewton per meter square. So this value now is our roofing sheet dead load. So if I'm considering only roofing sheet dead load now, in this place now, it will have been 0.04 as my, sorry, let me take it back, 0.04 kilonewton per meter square. This will have been our dead roofing sheet dead load. But don't forget that this is not all. We are going to be talking about what? Ceiling. The ceiling. Are we together? So the ceiling. So when I mean the roofing sheet finishing, we are talking about ceiling, isn't it? So now let's now say some use what? PVC. As I said, some can use PVC, some use POP or gypsum, isn't it? So some use any of those. So let us take gypsum board ceiling as what? As our example. Let's now calculate, isn't it? So as I said, it's going to be more of calculation. Now let me move it one side. So we have already calculated our roofing sheet itself as what? 0.04 kilonewton per meter square, which is here. So let's leave that one aside. Now coming to the gypsum board ceiling, we are now going to say we are taking an example. That's why it's very important for you to know the thickness of your member or roof ceiling that you want to use. That thickness is very important. If you can get the thickness you want to use for the roofing sheet, sorry, for the ceiling, that will save you a lot of stress. Is that okay? All right. Let's now cancel this one now. Let's assume we are using what they call it, 12 mm. That's 12 millimeter thickness of this board. Is that okay? So it's going to be 12 divided by 1000. We are converting to what? Meter. So give us what? 0.012. Am I correct? So 0.012. Now, how do you now know the density? The unit weight of gypsum is what? 8.5 kilonewton per meter cube. Is 8.5 kilonewton per meter cube. That's the unit weight of your gypsum board. Is that okay? So if you have this one now, multiply by your thickness of the board, which is a what? 0.012. Am I correct? Yes. Equals to what? Can you see? So based on this one now, what I'm now having is what? 0.102 kilonewton per meter square. This only for boards. Is that okay? This only for the weight of my board that I'm going to be using. So we keep it aside. Now don't also forget that you know that we have a suspended metal frame, which in terms of channels or hangers, screw and all of that. So based on all these hangers and screw, they have their weight. The weight is between 0.03 to 0.05 kilonewton per meter square. Are we together now? So if you are now taking the average of this, what they have been given to us as the screw values, screw, hanger, all those accessories and all of that. So if you are now using the average, which is a 0. Is between 0.03 to 0.05. So 0.03 plus 0.05. Don't forget we are taking average equals to what? This. Then divided by what? Divided by 2 give us what? 0.04, isn't it? So give us 0.04. So if you now get this 0.04 here, so total gypsum board ceiling now, are you getting it? So our total ceiling, total gypsum board ceiling is equals to what? Is equals to, let me now take it now. Based on what we have calculated before, we said our ceiling board is what? 0.102. Am I correct? 102 plus the accessories, the average that we have taken, the accessories, which is what? Which is plus 0.04. Am I correct? So give us what? Give us 0.142 kilonewton per meter square. So 0.142 kilonewton per meter square. So in summary of this, we can start to use what? 0.15 kilonewton per meter square. So which means that our ceiling board, both the accessory, the ceiling board itself, is going to be 0.15 plus all of this now. So I'm sorry, I'm coming. Yes, this is a 0.15. This is what we have calculated. So what we are now going to be having now is going to be 0.15, which is for the ceiling. This 0.15 now is for the ceiling. Is for the ceiling we are using, gypsum board ceiling, and we have known how we have calculated it from calculating the thickness of a gypsum, which is the density multiplied by the thickness, which give us 0.102 kilonewton per meter square, and went further to now add that of the screws, which is between 0.03 to 0.05. So we took the average of 0.03 and 0.05, give us what? Give us 0.04. So if you now add the total load of the ceiling now, which is now 0.102 that we have calculated before, plus 0.04 give us what? 0.142 kilonewton per meter square. So in approximation, we now say we are using 0.15. Now this becomes our load. This 0.15 now becomes our load of what? The dead load for the what? For the ceiling board. Is that okay? So if you now add this ceiling board load plus the roofing sheet load, all together now. So if you now add this gypsum ceiling board load, total load, plus that of the roofing sheet, what do we now have? Don't forget we have calculated the roofing sheet to be what? 0.04. Am I correct? So 0.15 plus the roofing sheet we have initially calculated, which is 0.04, give us what? Can you see? 0.19. So 0.19. So this is what we have now. So approximately we are having 0.2 kilonewton per meter square as our dead load. So which means that in this place now, what we are now having now here is now what? 0. It now be what? I think, what do we have? Let me check. Here's my calculator. Yes, 0.2. 0.2. Let me see. Let me come back. That's 0.2. So now this is what we now have as our what? As our roofing load, dead load. This is our roofing dead load now. So I'll now come here. Instead of enter this value now, 0.20 kilonewton per meter square. Then click on it, select it. Can you see it now? Then at this point now, I can now click on what? On OK. All together. So this is based on what? This is based on the kind of load we are using. Is that okay? So now, having gotten this one now, which then means that in this place now, we have our QK to be what? Let it update. Okay, sorry. GQ, where is it? Let it update. Update now. Why is it not updating? It's supposed to update. No. Sorry, it's supposed to update. It's supposed to update. This place was 0.6. We use 0.6, not 0. This. It's supposed to come up. So based on calculation now, let's now do it again. I'm coming. Let me delete this one. Let me delete it. I don't know why it's not responding. Okay, so I'll come back to this place now. All right. So my dead load, my life dead load is what? Is 0.2 that we have calculated now, isn't it? So I'll select this one now. Select it. Good and fine. So I'll come here now. My life load. Sorry, this is my life load. This is my life load. This is my dead load. This is my dead load. Sorry, this one is my dead load. Let me delete it. Let me delete the load. Sorry, let's delete the load. So I'll come here now. This is my dead load. My life load is what? This is my dead load. Dead load to be what? 0. Dead load 0.2. I'll select it. Sorry, let me come back. Okay, dead load 0.2 here. Then select it. Select this. Okay, we have it here. Then life load, you can see here. Then I'll come here now and turn to 0.6. Do you remember? Based on Eurocode. Is that okay? Enter this one and let's see. Can you see it now? So we now have our dead load and life load calculated, isn't it? Now, please don't forget that this calculation of this one is based on the kind of ceiling we are using and the kind of thickness of the roofing sheet. Let's now assume that we are using a PVC. If you are now using a PVC, it then means that your PVC, you need to know the thickness. Is that okay? You need to know the thickness of your PVC. So for you to use your PVC, your thickness of PVC, you need to know it. And once you have known it, what you are going to do now, we have the density of PVC. The density of our PVC is between 13 to 14 kilonewton per meter square. I want to cube rather, not square. Is 13 to 14 kilonewton per meter cube. That's the density of your PVC. So now you need to know the thickness all together now. So you need to know your thickness, and whatever you get from this your density multiplied by the thickness of a PVC, what do? You keep it. And once you have kept it, then you now look at the accessories. Are you hearing me? Your accessories, which is 0.15. So you now add it to it. We now give you the total load of what? Of your ceiling. Is that okay? Of your ceiling. So once you now have gotten that one, you now also add it up to that of what? Of your dead load of the roofing sheet itself. Just as the process we have followed now is what we are going to follow to the end. Is that okay? All right, that is fine. When it's now come to POP also, when it comes to POP, so POP thickness is usually around 15. Is that okay? It's usually around 15 millimeter. So the same thing, and the density is the same thing that of a gypsum. Is that okay? Which is 8.5 kilonewton per meter cube. So if you now know the thickness, it then means that your 15 thickness of your POP multiplied by, after you have converted to meters, is that okay? Multiplied by density, which is 8.5. Whatever you get, you do what? You keep it aside. That gives you the thickness of your what? Of your, sorry, the density or the weight of your POP. Is that okay? In kilonewton per meter square. And also don't forget that when it comes to POP, the average of those what do you call it, accessories, your screw, all those things they normally use, all those things they use, the average is between 0.04 to 0.05. So if you take the average, they're just approximately 0.05. So which means that when you now do your calculation, of your thickness of your PVC, of your POP, which is 8.8 density multiplied by the thickness, which is 0.015, understand, whatever you get plus this 0.05 gives you what? The dead load of your ceiling, which you now add to the load of the kind of roofing sheet they are using. You know, don't forget the way of calculating the roofing sheet is the same. Is that okay? 78.5 kilonewton per meter cube multiplied by the thickness of your roofing sheet. Is that okay? Which you now add it to whatever thing you have gotten from this particular one becomes your total dead load that we are using for this particular roofing sheet. Is that okay? So that is how to go about it. Now, the point is, after which I now click on what? On OK. I'll click on OK. I'll click on OK. So that is that. This one now we have loaded it. So this is how you go about the calculation. Alright, now this is how you go about the calculation of your roofing sheet. Don't forget that the self weight based on ProtaStructure, the self weight of this your member have been calculated by the software. All this poline, top chord, diagonals, what do you call it? Diagonals and the bottom chord, they have all been calculated by the software. So you don't need to bother yourself about that. So what you are now calculating is your roofing sheet load and all the ceilings. Is that okay? They are going to be using here, which I've already explained them. Is that okay? All right, that is fine. Now, and also don't forget that you might have seen us using maybe 0.7 as our dead load only. We don't apply life load. The question now is, are we safe? I can say yes, we are still safe. Now, if you are going to be looking at the factored load, what we have just done, is that okay? What we have just done now, if you have to go by it, so it's going to be, don't forget we have calculated our dead load to be what? 0.2 and our life load 0.6. So if you have to go by this now, go by this and factor it by ourselves, let's now see the value we are going to get. Is that okay? Manually, let's now see the value we are going to be getting. Is that okay? So when we say based on Eurocode, we have our factor load is for dead load is 1.35. Sorry, let me cancel this. Dead load, to factor load now of this our calculation, we said our based on our calculation, our dead load is 0.2 and our life load is 0.6, isn't it? So that is fine. So let's now factor it, factored load now. Based on Eurocode, it's going to be 1 point let me also carry my biro. That's why I say you should carry your biro. I'm also going to carry my biro. Let me see. Okay, let me look for a place here. Is that okay? So we are going to say 1.35 multiplied by 0.2. Am I correct? That's our dead load. Is that okay? That's our dead load. 0.2, yes, 0.2. Give us what? Give us 0.27. So then dead load is equals to 0.227. Am I correct? And don't forget, it's going to be what? QK, our QK or GK. Let me start with GK. GK is equals to 1.35. Am I correct? Plus 1.5 QK. Is that okay? That's what we are having. So now we have calculated our dead load, which is our GK. Am I correct? Which is our GK to be what? 0.27. Am I correct? 0.27. So let's cancel it. So now come to our life load now. Is that okay? Life load, which is a 1.5. 1.5. If it's a BS code we are using, that's 1.6. Is that okay? 1.6 life load and 1.4 dead load. Is that okay? But we are using Eurocode. So therefore multiply by 0.6, then you give us what? Give us a 0.9. Am I correct? 0.9, isn't it? 0.9. So if now add them together, what's our total load now? Factor load. Our total factor load is going to be what? 0.9 plus 0.27 equals to, can you see? Equals to what? Equals to 1.17. This is factor load now. Is that okay? This is our factor load 1.47, isn't it? So that is that. Now, if you now use a 0.75 as dead load, what does that mean? It means that you are not applying the life load value, factor load. We are only going to apply the factored load of dead load. And you know that our dead load is what? It's 1.35, isn't it? 1.35. So if you now multiply it by 0.75 that we are using as your dead load, is that okay initially? So it's going to be 0. Let me see. 0.75, am I correct, that we are using before, multiplied by 1.35 equals to what? Can you see? You can also, we have a what? We have this one to be what? 1.0125. Can you see now? So we are still on the same page. Is that okay? The difference is not much. So if you now check it now, so we have initially 1.17 based on the one we just did now, minus 1.0125 gives us what? Can you see? 0.15. Can you see it now? So this is what we are having as what? As difference, if I do the calculation very well. So this is how you go about your manual design of your roof, manual calculation of your roofing members. Is that okay? So from what we have discussed now, even when it comes to this your roofing without steel, we can use this experience to calculate the roofing sheet value, so the roofing load value. Is that okay? Roofing load value on your what? On your member, that is on the concrete. Is that okay? And apply the load on your what? On your beams. Is that okay? From this one now, you can use this experience to now calculate and do what? And apply the load on what? On your roofing members. That's your roof beam now. Can you see it now? So that is that. So this is how you go about manual calculation of your roofing sheet or roofing member. Is that okay? So that is that. So thank you very much. Till I see you next time in our next video. I want to say, please give this video a thumbs up and also subscribe if this is your first time. Is that okay? And also tell others about our channel. Thank you very much. Till I see you next time in our next video. Bye. Your comment is also very important. Your comment is very, very important. Is that okay? So that we also know the area in which we want to really expatiate more. Is that okay? Thank you very much. Till I see you, I want to say bye.